Welcome back to our attendees. We are back with our next speaker, Mr. Jonas Lindvall, CEO at Maha Energy. Over to you, Mr. Jonas.
Thank you very much, Melvi, and thank you very much for allowing us to be part of this event. Before our talk, I was just complimenting Melvi on how slick this whole setup was, and we're quite impressed with it. So, my name is Jonas Lindvall. Like Melvi said, I'm the CEO of Maha Energy. We are an upstream oil and gas company active in 3 countries, and now also in Oman. We are an upstream oil and gas company. That means that we export produce for oil. However, we are 100% focused on extracting leftover oil and gas that other people have left behind in the oil and gas reservoirs. So my talk is really centered around how we extract left behind assets and how to make it profitable. That means that we really are maximizing the total value of the oil that is already discovered and is being produced, and hence the very long and mouthful of the title here: monetizing stranded and mature hydrocarbon assets. And one size does not fit all. We are a company full of engineers and geologists that we tailor all the solutions to all our assets in one particular way. So I will be presenting also a real life example of one of our success stories from United States. But I want to underscore that doesn't necessarily mean that all our other assets are less successful, quite the contrary. But the one I will talk about and go into a little bit more detail is quite unique in that we can see how technology really is unlocking more and more value from the hydrocarbon or the oil pool. So in essence, I will be talking about oil today. Let's see here. Past the disclaimer. So a little bit about our company. I mentioned we are present in 3 countries. We are listed in Stockholm on the Nasdaq stock exchange. We're present in the United States. We are in Oman, and we are also in Brazil. The underlying theme in our company really is that we were founded by engineers and geologists is to create the value. Every barrel that we produce has to have a value. So I mentioned that we will be talking about oil. So I would be remiss not to remind everybody that we are still living in a very, very fossil-driven world. This is a graph that I downloaded from the web from Our World in Data. They do excellent schematics and pictorial representations of how we live our world. I recommend everyone to visit their websites. But this one shows that still, even today, some 55 years or 56 years after 1965, we're still using up to 85% of all our energy comes from fossil fuels. And that is split pretty equally between coal, gas, and oil. And of course, in our industry, in my industry, we will be focusing on the oil side. Oil and gas and coal, being fossil fuels, have been the sort of choice. Well, it has been the choice of energy throughout the recent ages. And the primary reason for that is it really is difficult to compete with the hydrocarbons. They pack an extraordinary amount of energy per unit. They're also very easily transportable. If you take away gas, for example, oil and coal is easily transportable, making it an ideal energy source for growth in remote parts of our planet. So this is why we focus on oil. We believe that oil is here to stay for the foreseeable future. I think that the energy transition is very alive and well, but as we'll see on the next slide, we're still growing our oil consumption on a year-by-year basis. This isn't a graph that I've prepared many years ago and I update yearly. This shows global oil demand. Now, I have to caution everybody that you will see a lot of different figures for what our global oil demand is on an annual basis. It's very difficult to ascertain exactly how much the world consumes on a daily basis per year, because it's split into oil, natural gas, liquids, distillates, etc. But this is the best representation I can find. It's from the Energy Information Agency, which is a US government agency. And they provide really, really good, solid data, I think. But what we see on this graph is really how oil demand has grown pretty much linearly since the early 80s. And that is despite the OECD countries actually reducing the oil demand for the OECD countries are actually declining on a year-by-year basis. But of course, the developing world, particularly the Far East, Asia, and now also making great strides onto the scene is Africa. They are making up for the reduction of oil and gas usage in OECD countries. Another important note on that is, of course, is that our cars have been getting a lot more efficient. So as we replace our car fleet, we actually reduce the consumption of petrol. If you then add to this graph the natural decline of oil production, like everything else, oil is a finite resource, and therefore, as soon as you start producing an oil field, it goes into decline. That global decline is about 4.5 to 5.5% per year. That means, in real terms, that the oil and gas industry has to replace up to about 6 million barrels per day per year, as it stands today. We can just see that back in 2018, we passed the 100 million barrel a day consumption mark for oil. So that really makes it a prime task of the oil and gas industry to keep supplying the world with this energy requirements. So I wanted to focus on what we do really is, and that is we go back to existing hydrocarbon assets, oil fields, and we go back and we apply state-of-the-art technologies to extract more. So this is a study that was conducted by the United Kingdom Oil and Gas Authority on the North Sea, the UK continental shelf. They have some 70 billion barrels of oil in place, and they estimate that their recovery factor, the total amount of oil that they will recover from these oil fields, is about 43%. And that's a pretty high number in our industry. But that really means that almost 60% of all the oil that has been discovered, and this applies to the North Sea particularly, is left behind. So we, in Maha Energy, we use our petroleum engineering skills to extract, to go in and try and extract more out of that 60%. So, for example, in the UK, they calculated that just by increasing the recovery factor by 1%, so you go from 43% to 44%, they can add an additional 340 million barrels of oil to the system. And that is not insignificant. So lots of money and lots of resources and a lot of research goes into the field of enhanced oil recovery or improved oil recovery. So up here we see the traditional on the upper right-hand corner on this graph. We can see how a typical oil field will behave. So you'll find it, you'll appraise it, and then you'll develop it, and you'll have a sort of a peak production, and then it will go into natural decline. That's your yellow curve. As the field matures, we can add water floods, we can do additional recovery technologies, and we get these secondary and tertiary bumps. So we're in the field of the secondary and tertiary recovery areas where we try to add value to the oil field. And of course, the area under that graph, that is the total production of that particular oil field. So in the UK, in accordance to this study, they believe that they can unlock an additional 900 million additional barrels to existing fields, and they identified 26 mature fields in the North Sea that they can apply these technology. Now, recovery factors, they tend to increase with time as the oil fields and the basin gets more and more developed, more and more better technology gets applied, and so does the original oil in place. As we can see on this schematic at the bottom, you can see from in the UK, you've gone from 60 billion barrels STOIIP in 2004 to 73 billion in 2016. And that's because smaller nearby pockets are discovered as infrastructure is built. So you can add on smaller fields economically. But you can also see that the recovery factors increased very, very small, from 42 to 43%. And that's because of technology advances and economic conditions. But working against that is that the newer fields that we're finding today, they're more complex, so they're not easy to develop. But the key note here is to take away is that recovery factors tend to increase with time, so does the size of the basin, but counteracting that is the complexity of the fields. So in our case, in Maha Energy, we operate 3 producing assets, 2 in Brazil, and actually 4 assets, and 2 in the United States. And in all those assets, we have gone back to existing discovered oil and gas fields, and we've applied new technology in one way or the other. They're not the same. We do not have a patented technology, but we do have the expertise. We have hundreds of years, combined years of experience in the petroleum engineering sector, where we find the right solution for the particular oil field that we're looking at. So, for example, in the US, we recently just, these are small wells in the US, onshore US. Just by adding some new technology, we increased production from a typical well in Wyoming from 85 to 145 barrels. And that's a significant increase in extraction percentage. And our second field, we recently and consistently have increased ultimate recovery by 30%, and also initial productivity of all our wells there. And I'll dive into that a little bit more in detail here. And also in Brazil, just by the application of fairly bog standard technologies such as horizontal drilling and jet pumps, we have increased production from one field there by over 300%. And the key there was really the jet pumps. The previous operator was suffering from gas production, gas locking problems downhole, and we solved that by just introducing jet pumps in Brazil. So I wanted to go and dive into a little bit deeper into what we did in Illinois Basin. We picked this up last year during the beginning of the COVID. And this is a very mature basin. It was discovered back in 1850s and has produced billions of barrels, thousands of wells. And here we apply high pressure hydraulic stimulation technologies. And we see the history of how this has evolved. So in essence, when high pressure stimulation technologies started making big inroads in the United States in the late 2000s, we picked that technology up, and we have increased the amounts and the volumes, but also more importantly, we have increased the amount of microproppants and the sand content on each frac. And what that does, it just connects the reservoir, the natural fractures of the reservoir. It just connects them more, and it allows us to pull down more oil. And the result of this has been quite astonishing. And what's nice about this area is the predictability. The very low risk, and we've increased the ultimate recovery of these wells by 30%, and the IPs have on average been just over 30%. We've had wells that have been well over 150% increase compared to what they were just 5 years ago. And there's more to be done here, just by batch stimulating wells, the geometry of these wells, how we drill them and how we complete them, will add more potential extraction of value in this area here. And just to give you an idea, at $65 per barrel WTI prices, each well will add another almost $1 million. And we're talking about the possibility of adding hundreds of wells in this particular area. Of course, at lower oil prices, this becomes a little bit more challenging, but at 65, these are very, very robust and very low risk projects. Here we can see how the rock is naturally fractured or cracked, and the idea here is to use smaller and smaller sand particles to penetrate those fractures, to keep them open and allow more oil to flow to the wellbore. Another very key thing that we have done is that we have added, we've looked at the chemistry of our fluids. So, for example, as you know, water does not carry sand particularly well, so we have to add polymers to create some viscosity, and that is a formation damaging substance. So we have worked very closely with chemistry labs to figure out on how best to break those polymers and also increase the lubricity of this fluid as we are pumping it into the rock. So that's a real life example of what we have done in, for example, in the United States. But like I said, we've also done very similar things in other assets that we have. So the message here really is, we can and we should explore for more hydrocarbon, but given the energy transitions that we are facing, I think we should try and optimize and maximize the recovery of what we already have. It's almost like making sure that the food plate is completely empty before we put it in the dishwasher. So with that, I'd wrap it up, and I think I'm almost out of time here, Melvi. So I'm not too sure if there are any questions.
You're just on time, sir. Okay, some of the questions coming your way is a unique question. What is your opinion about the heavy oil production in Oman and the region in terms of investment required and economic benefits associated with it?
Well, I know Oman extremely well. I've been in and out of here since 1986. So in Oman, I can only speak for Oman, but I think the heavy oil situation in Oman, in fact, the project that we are undertaking here is heavy oil. It is absolutely very, very, I'm very optimistic about the heavy oil here, but I think that there will be a need for more infrastructure. So for example, one way that Canada tackled their heavy oil was through cracking, introducing cracking or simple refining basically of that. And I think that if you're serious about extracting the whatever it is, 5 or 6 or 7 billion barrels of heavy oil here in Oman, you will have to look at some sort of refining process there.
Okay, a question from Nasser Ali Ahmad Al Kindi. What is Maha Energy plan for Oman Block 70?
Well, like I said, that is our asset here in Oman, and the plans there is to start a pilot project on an already existing and appraised heavy oil field that has been here. It was discovered in 1988, fully delineated. It's been tested, and our plans are to run a pilot stage on that, and then and providing positive results of that, we will develop it.
Another question from Mr. Dishon Munshi. So will Asia and Africa not have the opportunity to jump the demand and move straight to hydrogen and not increase the oil demand as you project?
That's a good question. I mean, we're talking about the energy transition, and we can talk hours about that. I don't think we have time for that, but I do believe that realistically, when you look, and I mentioned this at the beginning, the problem or the blessing or the curse of fossil fuel is that they pack one hell of an energy punch, and it's easily transportable, it's available. If you look at a coal, for example, there's no shortage of coal, even oil. According to BP statistical review, there's 1.3 trillion barrels of oil left to be recovered that are considered to be proven around the world. So I still think that for the cost per unit, it's hard to ignore oil and gas.
Okay. Another question from Shanley George. What is the current activities of Maha in Oman?
Well, we're in early stages, and unfortunately, COVID has played a havoc on us. We're looking forward to the borders opening up so we can get boots on the ground and get started with our program. So we are just in the infancy.
Okay. Any other attractive projects which we can see Maha getting into in Oman or the region?
Well, we're always looking, but right now I think we have our hands full with Block 70. We plan on dedicating the required resources to get that off the ground as soon as possible. We are working really hard to get that, to start monetizing that asset, not only obviously for our company and our shareholders, but also for the government of Oman and the people of Oman.
Done, sir. So attendees, if you all have more questions or you want to know more about the products and services of Maha Energy, please do visit the exhibition booth, and you can check out their products, services, and meet their team. Thank you, sir, and hope to meet you soon.
Thank you, Melvin. Thank you.